In this video, I will show you how to build an API using ChatGPT and then sell it. In case you didn't know, Rapid API is a marketplace for buying and selling APIs. Take a look at this.
What does that mean?
Football Live Score API.
I don't know exactly what API is.
Weather API, Recipe API. These APIs are making lots of money. All APIs have subscription plans, so it will be monthly recurring revenue. Let's check out APIs in the Tools category. QR Code API, Temp Mail API, Facebook Video Download API. Take a look at this QR for Python Flask API server that takes GET requests with URL as a string and converts it to QR code image and sends it back as API response. Now ChatGPT is generating code for our API. You have to be specific about your API functionality, so that ChatGPT can generate code according to that. As I mentioned, get method and taking the URL parameter and returning the QR code image. Let's copy this code and paste it in the qr.py file. I need to write some code here to start the server. Also import IO module. Now let's run this with command python qr.py. Server is started. This is the demo request. Copy and paste this in the search bar. And we got our QR code image. Let's change the URL value. We got a new QR code image. Let's check the server logs. This is working.
Wow.
Let's make the response image downloadable. Now check.
Plot twist, this whole channel is ChatGPT making YouTube videos as a side hustle.
ChatGPT is modifying our code so that the QR code image gets downloaded automatically. Copy this code and paste it in the qr.py file. Let's run this file. Our server has started. Send the request by refreshing the page. And you can see that image is downloaded. Let's try a few different URLs.
So this guy's created a server with a few lines of code? Remote. Right. A. Wow, okay, let me figure out what exactly they were doing.
URLs. And every time the image gets downloaded automatically, our API is ready. Now it's time to deploy it to the cloud. I will use Python anywhere, but you can use Amazon or Google Cloud or any other platform. Just sign up and you will see this dashboard. Click on Open Web App. Click on New Web App. Click on Next. Click on Flask. Choose Python version. Click on Next. Scroll down and click on Go to Directory. Open this file. Copy and paste our Python code here. Save this file. Click on Web. Reload our server. Let's open this in a new tab.
I completely got lost
This
there.
error is just because we don't web. Click on New Web App. Click on Next. Click on Flask. Choose Python version.
So I don't know
Click
exactly
on
what it's
Next.
doing here.
Scroll down and click on Go to Directory. Open this file. Copy and paste our Python code here. Save this file. Click on Web. Reload our server. Let's open this in a new tab. This error is just because we don't have any default route. Copy our demo request query parameters with path and paste here. And the image is downloaded. Let's try another URL. Our API is live and working. Now it's time to publish our API on the Rapid API website. Go to rapidapi.com and sign up. Click on New API Project. Fill out some details. Click on Hub Listing. Fill in some details about your API. Enter the base URL of your API server. Now click on Endpoints. Add the endpoint route. And add query parameters. Save this. Click View in Hub. This is a testing area to test whether our API is working or not. Click this button, Test Endpoint. And you can see, we got response code 200 and QR code image as response. Let's add pricing. You can set the price to anything like. I just set up 3 plans for my customers. We are done. Our API is live and available for everyone. When someone subscribes to our API, we will get paid.
What are
Let's
they
check.
doing?
Search for QR code API. And my API is shown on the 3rd page.
Okay. Unique and powerful use cases for.
It's been a couple of weeks since
Oh my God, the audio.
ChatGPT has been released, and it seems as though every single day people are finding new and unique use cases for ChatGPT. So in today's video, I'll be going over 17 of my favorite fun and powerful use cases for ChatGPT. The first and one of the most popular use cases for ChatGPT is its ability to explain difficult or complex subject matters. All you have to do is ask ChatGPT to explain what that concept or subject matter is that you're trying to learn more about, and it'll give you an explanation of that subject matter.
And this is the interface, fundamentally speaking. So you can see that you have their Discord server at the bottom here, and you can switch to a light mode or a dark mode, and you can, check the latest updates and the FAQ pages. And you can create new chats here. So I'm currently interacting with it here, and it gives you very useful starting points. So you have examples, capabilities, and limitations. And we're going to be taking a look at a couple of examples, both on the red team side and the blue team side of things. So just keep that in mind, and you'll actually see how powerful this is. So to get started, how does this work? Well, you essentially ask it a question. All right, that's very, very simple. Very simple question, right? And this is how it'll respond. So it'll say red teaming is a method of evaluating the strengths and weaknesses of a plan, organization, or system by simulating the actions of an adversary. We can then,
Fuck.
It's a very Nmap. You can use the following, but I can say, I can ask the question here of both offensive and defensive security. But I can say, I can ask the question here. Now, this is one of the issues with its verbosity, in that it gives you a definition of Nmap, which is very, very helpful. But it says to scan it to the actual specified scripts, but you want a nation enable doing this. However, this as well is now. We can try out a couple of other examples. So, for example, I can say generate a PHP reverse shell one-liner. Now, this is you may be asking yourself, can it do this? Well, of course. So it gives you the definition of what a reverse shell is, and then absolutely incredible, it provides you with a PHP reverse shell one-liner and explains how it works, fundamentally speaking. I mean, this is absolutely insane. Now, follow-up question that I could ask is encode the code above, and then right over here, it tells us, to encode the PHP reverse shell one-liner. This is absolutely phenomenal. Further with a bit more nuance, so I can type that in correctly. How can I fuzz 4 XML files with GoBuster?
I want to figure out what the fuck that means. Fuzzing, shellcode, custom email. What does that mean?
May say so. Let's say a very well written email. So we can, for example, say, let's see. I can say write an email.
Buffer overflow automation.
The operations, but these are sort of the examples. Now, I'll touch on a couple of other examples for red teamers, and then I'll show you some blue team examples. So another one maybe could be, generate a bash script, and this is really cool, and I'll show you why. Bash script to that that automates port scanning with Nmap.
Oh.
All right.
Moving parts. So let's just have a quick
Okay, so let's check this out.
generating images using diffusion. What is that? Right. So I should probably find out.
Is this things like DALL-E and...
DALL-E 2, yeah,
Why is it
Imagen from Google, Stable Diffusion now as well. I've spent quite a long time messing about with Stable Diffusion. I'm having quite a lot of fun with that. So what I thought I'd do is I'd download the code, I'd you know, read the papers, work out what's going on, and then we can talk about it. I delved into this code and realised there's actually quite a lot to these things, right? It's not so much that they're complicated, it's just there's a lot of moving parts. So let's just have a quick reminder of generative adversarial networks, which are, I suppose, before now, the standard way for generating images, and then we can talk about how it's different.
Well, I don't know how to start it to begin with, so.
And why we're doing it using diffusion. Having a network or some deep network trained to just produce the same image over and over again, not very interesting. So we have some kind of random noise that we're using to make it different each time. We have some kind of very large generator network, which is, this is just, I'm going to go to black box, big neural network, right, that turns out an image that hopefully looks nice, right, like the thing we're trying to produce, faces, landscapes, people, you know.
Is this how those anonymous people on this person does not exist? Is this what?
Yeah, that's exactly how they work. Yeah, that's using, I think, StyleGAN, right, and it's that exact idea. And that's trained on a large corpus of faces, and it just generates faces, right, at random, right, or at least mostly at random. The way we train this is, we have, millions and millions of pictures of something that we're trying to produce. So we give it noise, we produce an image, and we have to tell, is that good or is that bad, right? We need to give this network some instruction on if this image is actually looking like a face, right? Otherwise, you're not going to be able to train it. So what we do is we have another network here, which is sort of like the opposite, and this says, is it a real or is it a fake image? And so we're giving this half the time we're giving it fake images and half the time we're giving it real faces. So this trains and gets better at discriminating between the fake images produced here and the real images produced from the training set. And in doing so, this has to get better at faking them, and so on and so forth. And the hope is that they just get better and better and better. Right? Now, that kind of works. The problem is that they're very hard to train. Right? You have a lot of problems with things like mode collapse, where it just produces the same face. If it produces a face that fools this every time, there's not a lot of incentive for this network to do anything interesting, right? Because it's solved the problem, right? It's beaten this, let's move on, right? And so if you're not careful with your training process, these kind of things can happen. And I suppose intuitively, it's quite difficult to go from this bit of noise to a really beautiful looking image in high resolution without there being some oddities, right, and some things that go a bit wrong. So what we're going to do is, in diffusion models, is try and simplify this process into a kind of iterative small step situation where the work that this network has to do is slightly smaller, and you just run it a few times to try and make the process better. Right, we'll start again on the paper so we can clean things up a bit. So we've got an image, right, let's say it's an image of a rabbit. Right, we add some noise, so we've got a rabbit, which is the same, right? And you add some noise to it. Now, it's not speckly noise, but I can't draw Gaussian noise, right? And then we add another bit of noise, right? And the rabbit, it's the same shaped rabbit. There's a bit more noise, right? And then we come over here, and we come over here, and we end up with just noise. It looks like nonsense. And so the question is, right, how do we craft some kind of training algorithm, some kind of what we call inference? How do we actually deploy a network that can undo this process? The first question is, how much noise do we add? Why don't we just add loads of noise, right? So just delete all these images, and we don't need to worry about that. Add loads of noise, and then say, right, give me that. And then you've got a pair of training examples you could use. And the answer is, it'll kind of work, but that's a very difficult job. And you're sort of in the same problem as the GAN. You're trying to do everything in one go. Right? The intuition perhaps is that it's maybe slightly easier to go from this one to this one. Just remove a little bit of noise, and then...
I mean, I was following this for a while. I'm starting to get confused now.
From this one to this one, a little bit more noise.
Well, in traditional image processing, there are noise removal techniques, right? So it's not difficult to do that, is it?
No, I mean it's difficult in the sense
itself. Copy file. All right. I've